Good day, friends. Welcome back to Swag Kite. In today's video, we are going to be solving another problem on electric field. The first part of the question says that find the electric field strength at point P. The electric field strength at point P, distant 50 centimeter from a watt, -2 microcoulomb. The first part of it is that, let's sketch it out. Here is a -2 microcoulomb charge, right? And at a distance of 50 centimeter, we got another point called point P, right? This point P, right, we want to calculate for the electric field being felt by this. We know for a positive charge, the electric field radiates outwardly. For a negative charge, the electric field radiates inwardly. So definitely it will be coming inside due to what this negative charge. So we need to bring out our given, right? We know we are asked to find the electric field, which we don't know. They said the distance is r equal to 50 centimeter. So we have to convert that to meter. That will be equal to 50 times 10 to the power of -2 meter, right? Or we can say that is equal to 0.5 meter. The last thing here is the charge. So for the charge, we say Q equals -2 microcoulomb. Now, let's find for the first part, the electric field. The electric field we know is calculated using kq watt over r squared. Now, k is a constant and it has a value of 9 times 10 to the power of 9, right? And then q is given. But one thing I want you to note here is that whenever you are calculating for the electric field, you don't consider the negative sign in the charge, right? We only pick the magnitude, which is the absolute value of that charge. So in this case, it becomes +2 times 10 to the power of -6, all divided by 0.5, which is the distance. But remember, we have to square it. Now, the next thing we need to do here is that we say this equals to 9 times 2 times 10 to the power of 9 minus 6, if we keep simplifying, divided by 0.25. That equals 18 times 10 to the power of 3 divided by 0.25. This will give us a value of 72000, right, Newton per coulomb. In essence, the electric field E equals 72,000 Newton per coulomb, right? So the second part of the question, which is the B part of the question, says that what is the magnitude of the force experienced by a proton at point P? So that simply means that at point P, we are going to place a proton, right? So here is the charge, -2 microcoulomb, right? And at a distance of 0.5 meter. Here is point P. Now, since this is point P, we have to place a charge, which is proton, right? P, right, equals, and we know a proton has a charge of 1.6 times 10 to the power of -19, right? So if that's the case, to calculate for the electric, the force field strength, right, the force F has to be equal to Q1 Q2 over r squared. But since we know that this part of the problem is already solved, which is the E, right? So we say, okay, F equals to Q, and this Q is the proton, or we say Q2, then the E. So F equals the value of this proton, the new one, times 10 to the power of -19, and that of the electric field, which is 72,000, right? So therefore, if we keep simplifying, we end up having F to be equal to 1.152 times 10 to the power of -14 Newton. So we've calculated for the electric field and also for the force. If there is any question, feel free to ask in the comment section and I'll be there to see you. Goodbye.